in a smart way that how can we can achieve, okay, this algorithm fails, okay, this combination fails, so let's try out the next thing. So after doing this several amount of the trials, we have found that, okay, so this is the same way of representation. You see, healthy, it is predicting 100%. In case of the grade 1, it is predicting correctly grade 1 as 85.45%, while wrongly predicting grade 1 as grade 2 14.54%. In case of the grade 2, it is predicting grade 2 correctly 78.57%. It is predicting wrongly as grade 1 21.43%. It is predicting grade 3 correctly as 100%. Okay, so normal grade 1, grade 2, grade 3, you can see, you can look that grade 1 and grade 3, or I mean normal and grade 3, it was earlier, it was also good, here it was also superb. But grade 1 and grade 2, which are the main challenge to detect the early stage cancer, we have made a significant improvement from 55, 57 to 85, or nearby 80 percentage accuracy. So now it is quite acceptable range, because early stage, due to very submicron level changes, very difficult to quantify them, and it also got mystified because of the huge amount of the stray lights. Because see, we are doing it on the in vivo data, not the in vitro data on the dark room experiment samples. We are doing it on in vivo data, and in vivo data, as I told, huge amount of the challenges of the cleaning and pre-processing. So you can't, and we are from engineering background people, we all know that we can't remove noise 100%. So there will be always some unwanted signal interferences. We can reduce the possibility of noise interfering. We can do background extractions, we can do normalizations, followed by, for example, Fourier pre-processing. You can bring them in the Fourier domain. You can remove the noise, because that will become in the multiplicative format, as we discussed. Because in spatial domain, noise and signal is in a convoluted format, but in frequency domain, it is in a multiplicative format. So you can see, we require the knowledge whenever we are working in the healthcare domain. We require the knowledge of signal processing, image processing, computer vision. We require the knowledge of optics, especially biophotonics. We require the knowledge of machine learning, deep learning, whatever we may call. So basics are always important. We are starting from the basics, from the second year, third year study of engineering, signal processing. Then we are going to image processing, then computer vision. Then we are using biophotonics, or optics in general, and then we are going to AI, machine learning, deep learning. So wherever you may apply the high level of methods, if your pre-processing step is not correct, you will not get the success. So basics are always important. Linear algebra to signal processing, everywhere we have to give the emphasis, we have to check the basics, because those essence will definitely come to play in the significant role whenever you are dealing with real world data, because this is the real world data. This is not any kind of synthetic data we are dealing with. So real world data, noise will come, and it is very challenging task to get even the 80% accuracy under this huge noisy system. So we have seen that how using the hidden Markov model, we comparatively achieve the better result. And we remember that we have, as a representational basis, we have shown these two examples. But don't consider that we have only tried out with these two hybridized model. We have tried out several ample amount of the models, because we have shown you just two models, that these two are giving us the optimum result. But HMM is the best in terms of dealing with the noisy system, Bayesian model. So all of you who are working with the highly noisy system, I would request you to try it out, hidden Markov model or any kind of dynamic Bayesian model. You will get definitely a fantastic result. So now one thing we will deal with, for example, we have seen that cancer is one of the light threatening disease. Now optical coherence tomography image we are taking of the human retina, here we'll be judging the diabetic macular edema. So this particular research project, we have collaborated with LB Prasad Eye Institute, Hyderabad. Dr. Jay Chabrani, one of the eminent ophthalmologists, now he has shifted to US. So somehow, anyway, so this is also the major reason of the blindness. So remember that we are considering the chronic diseases, life-threatening diseases, vision loss, because diabetic retinopathy, diabetic macular edema is one of the reasons, along with the diabetic retinopathy, for the vision loss. So that's why we have also took this particular challenging problem. So what we have done, we have OCT can extract the depth resolve index in variations, acquired in vivo retinal OCT, so we are also capturing the in vivo data here, then crop different layers of retina, then extracted depth resolve optical index variations of different layers. Then we have analyzed via MFDFA to extract alteration of multifractality due to progress of diabetic macular edema, and and age-related macular degeneracy. Because after the age of 50, some people have the diabetes, so they suffer for the vision loss due to diabetic macular edema. Okay, so that's why we call it also age-related macular degeneration, AMD. Abbreviated from, we write it AMD, age-related macular degeneration, or diabetic macular edema. We call it as DME in abbreviated format. So you see, there are different retinal layer informations are given, and you see we have how we have mapped them, and now we will check that we have also done the Z-axis scanning. You can see OPL layer far from DME and OPL at the edge of DME. We have also checked the Z-axis scan, and then we have checked that what is the activity. We have chosen one layer because there are multiple amount of the layer. So as a representative layer, we have considered OPL layer, or outer plexiform layer. The full form is outer plexiform layer. So you can see the Z-axis scan result far from DME and at the edge of DME. So this is the dynamics you can observe. Okay, now we will see that we will apply multifactorial dependent fluctuation analysis here also, MFDF, as a statistical biomarker as well as feature extractor. So what is happening now? We will see. Look, so we are considering, as I told you, that outer plexiform layer, and now you see this order of movement we are considering here +4 to -4. So we'll first test the presence of the multifactoriality. So here you see these lines are not parallel to each other. So as I told, if the parallel, then monofactorial, but due to low scale variations it will not be parallel, so there will be certain shift. So this is not parallel at all. So now we are going for measurement. There are presence of multifactoriality. That means H equals to, then we will see that Hus exponent plot in figure A, and figure B is the singularity spectrum with plot. So here remember that in earlier case we have done multi-class classification. Here we are doing binary classification, either healthy or the DME affected layer. So we see that in case of healthy OPL, you observe that the Hus exponent value is 0.61. DME affected OPL, you see the value is 0.52. Okay, so again there is a reduction in the correlation level. When we are proceeding from the healthy to diseased tissues, there is a reduction in the correlation level. Here you see healthy OPL layer, sigma value is 0.58. Whenever you are going to DME affected layer, the value is 0.94. That means the tissue surface heterogeneity is increasing. You can see the tissue surface heterogeneity increasing like the earlier cases. Okay, because what is happening due to progress of the diabetic macular edema in the retinal layer, there is what is happening in the submicron level, broken collagen fiber is there. Now healthy to disease, whenever you are progressing from healthy to disease, the broken collagen fiber phenomena is becoming more prominent, so surface heterogeneity increases. So what is happening, that at q quadratic order of movement, h equals to q2 in OPL of diabetic macular edema, indicates the reduction of the optical index correlation in progress of DME in the from figure A, and from figure B, the increment in the sigma value, it implies that in OPL of diabetic macular edema, DME indicates the increase of the strength of multifractality or the heterogeneity in layer due to progress of the DME, heterogeneity tissue surface heterogeneity. Okay, so now what we are doing in the same manner, we are representing them mean plus minus standard deviation values for layers like choroid, ONL, OPL, IPL, GCL, NFL layers. So from healthy and AMD stands for age-related macular degeneration. So we are also focusing for the geriatric care purpose, we focusing are over 50 years age, because over 50 years age, if somebody is suffering from diabetes, it becomes, if the diabetic macular edema becomes a major range for vision loss, so we call it as age related macular degeneration in the medical terminology. So you see in HQ equals to 2, you see there is a decrement. Healthy, if you compare between healthy and age-related macular degeneration, there is a decrement between the correlation level. In every case, you observe here, you see healthy and AMD, you can see there is an increment level of the surface heterogeneity in the sigma value. If you consider layer NFL healthy, NFL AMD, GCL healthy, GCL AMD, sorry, extremely sorry, GCL healthy, GCL AMD. So in this way, we can see. So we can conclude that implies the decrement in Hus exponent in Q equals to 2 implies that overall reduction in the depth correlation in of refractive index, but increment in the tissue surface heterogeneity. Okay, but here you see there are also overlapping. There are also standard deviation values, but there is no overlapping. Unlike the the earlier examples, several examples in the cancer domain, in eye disease like diabetic macular edema, there is no overlapping. But why? Because the number of sample is very less. We are experimenting with a number of samples which are very less. So under the lesser number of samples, this feature extraction or statistical biomarker like MFDFA can classify also. You do not require now to deploy machine learning algorithms because already it is classifying. But whenever you increase the number of the samples, there will be definitely overlapping, and you have to apply machine learning algorithms. But these nonlinear dynamics tools, I have given you both the examples. One, the nonlinear dynamics tool is not adequate enough to classify. You require machine learning algorithms to classify them. And another example, there is due to lesser number of the samples, nonlinear dynamics tool itself can classify. You do not require machine learning algorithms, but these are not the classifier. Coincidentally, it is classifying, but these are not the classifier. Because it has classified, we do not require any kind of algorithms, statistical classifiers. But this is a very, very significant tool. What you can rely on MFDFA if you are dealing with a biological tissue-based imaging or spectroscopy approaches. You can do the feature extractions. You can check you can pinpoint the progress of the diseases from early stage, healthy to disease progress, early stage basis pinpointing. It is fantastic, significant. But remember, for the large number of the samples, if you want to do the classification, then what you have to do, you have to take 2 or 3 MFDFA parameters like we have done here. You have to club them with different machine learning algorithms, and then you can get I should not use that term magic, because this is not a magic. This is a hard research work. So you can see the possible outcome. Okay. So these are the few relevant publications to this domain. Okay, the result I have presented here in the slides are taken from these are my publications. Okay, and now we will see, we already have covered the science technology part. Now we have, first of all, we have discussed philosophy, then we discuss science, then we discuss technology. Okay, now we are discussing on the product. Like I told you, the flow is philosophy, science, technology, product, and marketing. These are the 5 sets together once you are launching something to create impact on bottom of pyramid. So what are the solutions you are providing? So impact on BOP level, bottom of pyramid level. Pain-free early stage cancer diagnosis and low-cost portable device. Generate reports within a few minutes, where biopsy requires the several week times to come up with the report. Look how we are matching the problem canvas and solution canvas, what we discussed during the initiation of our talk, philosophy development, that this is our solution canvas, this is our problem canvas, this solution we will provide to overcome them. And you see, with our science and technological development, how we are overcoming them. In the final stage, automatic solution and highly efficient. So this is the app looks like. Okay, in the spectroscopic app. So the app it is a cloud analytics based app. We are also now developing the edge analytics based app as well. As I told you, that we are dealing with a very tricky algorithms. For example, how we can apply linear algebra in the reduction of the time complexity level. So we have talked about the nested for loop where the order of complexity was n square. We have vectorized them, we have unfolded them. So we are directly, instead of processing 2D images, we have unfolded them. So unfolding, as per the theory of nonlinear dynamics, unfolding 2D to 1D, first of all, gives you the more hidden features information, and secondly, in computational manner, it reduces of the time complexity from order of n squared to n, and it is required whenever we are dealing with a low processor devices like mobile phone. So if I get the opportunity in sometime in near future, I will discuss about our progress of the edge analytics, how we are dealing with this tricky time complexity algorithms, and we are coming up with some amazing results in terms of the edge computing based approach in the healthcare domain. So now, like you remember that I have skipped their unique selling proposition. I told you that we will gradually discuss during when we will come here. Now you see. So in terms of the selling purpose, selling point of view or marketing point of view, you have to highlight that what are the key features you are providing where your competitors are not. So basically replacing painful and cost-effective biopsy, 100 times cheaper than biopsy, accuracy greater than 95%, portable, lightweight, and 80 times faster than the biopsy. So in this way, one should present their product features. Then obviously business model, like I have told you that we will discuss about the revenue model during the marketing section, product and marketing section. So you see scan. Even if you charge 100 rupees per scan, if doctor charges 100 rupees per scan, still it is 100 times cheaper than biopsy. Or you can still sell the device once at a time in a hospital. So there will be no further cost will be associated with that. But this charging of these per scan basis charge is called software as a service. People who are aware of the cloud computing, they know software as a service, infrastructure as a service or platform as a service. So we are using it as a software as a service. As I told you that softwares are the new hardwares as per the philosophy of MIT in 2016, to reduce the product development cost in third world countries, developing countries. So being the people from the third world country, we have 96% people under the bottom of pyramid category. Can we create impact with our low cost solution on them? Can we bring the smile to their face? Whatever the limited capacity we have, that is an humble effort on this particular domain. So growth strategies. So these are the growth strategies. You know that you require samples to build a strong data set. So ongoing clinical trials in hospitals. You have to, as doctors are the ultimate decision makers. I told you that in healthcare domain, doctors are the ultimate decision makers. They have done 5 to 6 year studies in MBBS. They understand the cell biology pretty well, and cancer biology varies people to people. So even if your app is showing that these people do not have cancer, but doctor can understand from their sixth sense that even if that particular people may not have cancer, but there may be some other abnormality which is going on, and it may develop in next 5 to 10 years to a cancerous stage. So that's why doctors influence is very important, and that's why these products are available for a selected hospitals. Okay, and it is not available for a normal human being, because this is a very serious issue. This is not about measuring the blood pressure or something like that. So this is a very serious issue, and doctors can only judge that whether that particular people is okay with this particular best approach, or they have to do certain sort of the biopsy, or they have to take certain sort of the medicines. So that's why doctors monitoring is very important. But this is a very strong catalyst to making the cost reduction and increasing the precision AI based approach I'm talking about. So you can do the 50-50 revenue model sharing with doctor. So whatever maybe, I mean it depends upon your dealings with doctor. So the competitive landscape. So this is one of the, what is the unique value you are adding in the market. So that I also told you we will discuss during the product and marketing section. So in terms of the low cost, accuracy, smart device, data driven, cloud based approach, we are superior than our competitors in all kind of the aspects. So we are the first research group across the globe who have explored MFDFA in terms of the retinal disease predictions. So our appreciations as our research success has been appreciated by televisions like G News, Odisha TV News, All India News X, also the global news site like Yahoo News, Nature India. Also, we are featured in the leading newspapers like The Hindu, Business Standard, Indian Express, Economic Times. In cancer research success also has been featured in the leading newspapers like The Hindu, Business Standard, Indian Express, Analytics India Magazine, and Nature India, as well as our cancer research success has been included in the syllabus of India's most toughest and leading competitive exam, IBPS, IAS, UPSC, as well as banking exams. So we are the first runner-up of the MIT NASA hackathon as a global award, which took place in 2017 with this particular innovation. And definitely what we are now currently doing, you see the digital world is getting double. We have the exponential growth in the databases. So we know by 2035, according to the experts, whatever the processor power we have, even the supercomputer will fail to analyze this bulk amount of the data. And that's why we are proceeding towards the quantum computations using the entanglement property of the quantum phenomena. So now our challenge, what we are doing, we are mapping our classical algorithms towards the quantum machine learning algorithms in the healthcare domain. So we have already reported one paper in IEEE. Let's see what the fate of it. So basically now our main focus is to edge-based approach one, and the second one is the deploying quantum machine learning, keeping the future in mind, because it's not only about the accuracy, as I told you, it's also about the time complexity, and quantum algorithm works exponentially faster than the classical algorithm. So So, and apart from that, there is a limitations of the processor power. So how can we remove that limitations with the quantum computers? So that is another major challenge. So we are also putting our step towards that as a visionary steps towards that. So gradually I will keep on updated you about our progress. So whatever we are making, whenever the next opportunity will come up. So it is again stop presenter. So 2 or 3 slides are remaining. I am re-uploading it again. So kindly have some patience. So it is uploading. So only 2 or 3 slides are remaining. So kindly have some patience, please. So I hope I guess I have 10, 11 times already uploaded the slides. We uploaded the slides. So I myself also have some patience. It's really a testing of patience as an individual basis. Okay, so it has appeared. It is gone. The screen appeared, then where it is gone? So here, sir, only 2, 3 slides are remaining. Is it okay? I think already we have passed. It is 3:40. So will that be any problem if we hold on for 5 minutes? I am re-uploading it again, but there is some difficulties going on. Hello, Yog sir, can you hear me?
No, as you wish, you can continue.
Okay, only 2, 3 slides are remaining. So almost we are done. So that's why.
You continue, no problem. But it's not displaying.
Okay, thank you. It is not coming, so I am re-uploading it again. So already as today 12, 13 times I have already
Yes, yes,
re-uploaded
yes.
several intervals. Anyway, and some network error is going on, unfortunately.
That is not in our hands, so we cannot do anything.
Exactly. Okay, so it finally has appeared. So at the end of the day, I want to ask a very funny question. So we have already discussed about the explorations of signal processing, computer visions, machine learning, AI in the healthcare domain. So we have covered all the serious stuff. We have discussed that how we should develop philosophy, how we should take the help of science, technology, product, and marketing. So these are all the very serious stuff. Now, at the end of the talk, after the whole days of lecture, you are already bombarded with whole days of lecture, and you all are very tired. So, due to lighter note, I want to ask a very funny question. There is no science and technology behind that. If any one of you kindly volunteer to answer it, please continue. So the question is, what is the difference between a computer vision scientist and a film director? What is the difference between a computer vision scientist and a film director? This is a very funny question. There is no science and technology behind that. To wrap up my talk, I want to talk it in a lighter note because people are very much tense due to this pandemic scenario are going on, and I want all of you please stay safe and healthy. But can anyone want to answer this on a lighter note? What is the difference between a computer vision scientist and a film director? Is that just a funny angle of it? Anybody want to try it out? Okay, so
Perhaps,
let me tell you. Please, sir, carry on. Please, sir, carry on.
no,
Okay, okay. So let me tell it. Film director says light, camera, action, right? So computer vision scientists say light, camera, pixel. So that's a funny difference. And also we have talked about our ongoing studies and all. So basically we are exploring gradually in the quantum machine learning domain also. As I told you, we can overcome the processor limitations. And second one is the quantum algorithm works exponentially faster than the equivalent classical algorithms. Okay, definitely. So you can join me on the social media. These are my social media handles. If you have any query in future regarding deploying AI, machine learning, deep learning, or any other things regarding any support from the uh, multifactorial detended fluctuation analysis or any collaborative research work, I am free to collaborate. Uh, so thank you very much. Thank you very much for your kind patience. Uh, because there are so much due to technical difficulties, there are so much interventions has happened. But thank you very much for staying till the end, and I am thankful to Hirok sir and Deepak Kumar Mondol sir. They are my respected teachers when I studied my BTech in Kolaghat Engineering College. So those teachers are very generous enough to guide us towards the research directions, the benefit we got from the Kolaghat Engineering College. That I want to highlight that to build the research mindset up right from the beginning, from our BTech days. These teachers were phenomenal. From whenever I went to any teachers, whether it is EC department or any other department, computer science, mechanical engineering, any department, I would say they all was very kind enough to provide their extended support to explain the complex phenomena of engineerings. And definitely most of them I try to keep in touch with my professors, and most of them are in keep in touch with me. And it's a fantastic experience. I miss those days from 2008 to 2012. This 4 years was amazing days in my life. And when I moved to ISAR for doing my masters, I carried out those essence, because these strong foundations of signal processing, image processing, I remember that during our final year I took image processing as an elective subject. I am thankful to Professor Soibal Pradhan, who are the HOD then. He has given me the permissions that suppose that you are working in this research field, you can take this subject as an elective, because not much students were curious to take that subject. And you see, because of those guidance, because of those blessings, we are nowadays we are being able to deploy those things in a higher level of the research problems. And Hirok Maiti sir was our instructor in that time. Sori Sanal sir was also there as an instructor of those particular subjects. So it's not possible to take everyone's name. I am thankful to Professor Sukanto Samanto, Professor Bhattacharya, because I got the opportunity to present here. So I took few names, but I am thankful to each and everyone wholeheartedly, because it is your blessings that we have proceeded towards some extent in the research directions. And I am really feel proud as an alumni of CMK. Thank you very much. Thanks a lot for inviting me here, and keep on blessing me. Thanks a lot. Thank you.
Thank you, Sabbasachi. DKM sir.
Thank you.
I'm here
Yes, sir.
also.
Thank you. Yes, sir.
uh, if any participants have any question, please.
If any participants have any question, you can ask. Thank you, Shobhushachi,
Thanks a lot.
your whatever you have given the information. I have one question.
Yes, yes,
The
yes, sir.
question is that the macular disease which you just have defined and which you have just said that you have done work taking the data from diabetes patients. But does this disease comes in the normal people? That means those who are not having diabetes.
Chances are very less. It is more prominent towards people who have the diabetes more than 55 age. That's why we have concentrated on the geriatric care section. We are considering the patients for more than 50 age because that is the most prominent zone where people have chances of vision loss due to diabetes. But macular edema can happen in any ages, but chances are very lesser chance. It mainly happens towards the little bit of older people who has the diabetes. So that's why the name is diabetic macular edema. But in general, macular edema can happen, but chances are very less.
Okay, why I have asked this question because
Mm.
I know a person. He's from our college only, so he
Mm.
doesn't have a diabetes.